I was gonna sit outside.
Oh, it is.
Right. On the shark bite, which number or numbers do we want to see? Do you go over? Have questions about? 3.
2.
2.
Oh, you're so busy. Hey, I'll take the 3.
We have 2 and 3. Any others? Aaron? 5. Alright, numbers 2, number 3, and 5. We'll do those 3. Starting with 2. This is an evaluating problem. It says g of -4. Okay.
Oh,
So that's your x value. You're going to put that in for every x you see. And then you can either put that in your calculator all at once or simplify. So this would give us positive 16 plus 8 plus 5. 29. So g of -4 equals 29. Questions on that one? 3 asks about the range, the ordinance, the range of this function, of this relation. So in curly brackets, you would list them least to greatest. -2, 0, 1, 3. Noah, Paige, did you guys have questions about this?
Wow.
So you just list out the y values, least to greatest. Okay. Other questions on this? 5 on the back. There we go. Graph this inequality. Start at -2. Your slope is -4, so we can go up 4 and to the left 1 and keep doing that. And then go down 4 and to the right 1. This would be a solid line because it is equal to. And it's greater than or equal to. So at my y-intercept, if I draw an up and down arrow, up would be where it's shaded at. So this area over here. As a reminder, each of our shark bites throughout the year have been like little mini reviews that really help you review past things, that will continue to help you review past things, especially when we get closer to the final. So keep doing those. Okay. Any questions on 5? The lesson for today is on parallel perpendicular lines. You have 2 different sets of notes because we're going to talk about different aspects in both. So find the one that has this on the front. Look through, write this first somewhere on your paper. Parallel lines have the same slope, and perpendicular lines have negative reciprocal slopes. So same slope means it's going to be identical. Negative reciprocal, give me an example of something that would be a negative reciprocal. So let's say if I said the slope was 2, what would the negative reciprocal of that be? What do we think? Reciprocal means we flip it. Negative means it will either have a negative or it won't, depending on the original. So if the original was 2, what would the negative reciprocal be? It would be negative, it wouldn't be 2, because we're going to take it and flip it. Say it again.
2 over 9.
So not of this one, sorry, I'm just making up a random one. So not negative 2, but negative, how would I flip that? What would that be? What is 2 over? It's imaginary. We don't really see it, but what is it over? 1. So if I flip that, what would that become? But it would be negative 1/2. So negative reciprocals, you take it, you flip it. If it was positive, you make it negative, and vice versa. If we were doing that for this, but yes. So for this section, it's parallel, so the slopes have to be the same. So what would a parallel slope of, I'm sorry, first, I was going to choose, you guys choose. Which of this first section do you want to see, do you go over review? 1, 5. And I'll come back to this and you'll write that. Okay, so now repeating my question. If this has to be parallel, what slope would be parallel to this equation? Negative 9/2. So it would be exactly the same. Questions on that? Or before we get into number 5 and number 6, somewhere on your paper write this, your Hoylux. Horizontal lines have 0 slope and are y equals. Vertical lines have undefined slope and are x equals. But this only applies to y equals some number, x equals some number. If you have x and y in the same equation, this does not apply. So once you have that written down, look at number 5. What would be the slope that's parallel to the equation given? What is the slope of this? There's a number in front, it's just invisible. -1. So the parallel slope would also be -1.
That's 3, 1, 1. It's okay.
Right. For number 6, this is a y equals. So what would be the slope that's parallel to that? What is the slope of this? This is 0. So what would be the slope that's parallel? And equals 0. Has to be the same. Right? Any questions on this section or any others we want to see go over and review? Go on to the next page. And looking at this first section, 7 through 10, which of those do we want to see do go over review? Nine. Any others? So now we are writing the slope that is perpendicular. So take the number, flip it. If it was negative, make it positive. If it was positive, make it negative. So what would a slope that's perpendicular to this one be? Aaron? Sorry. Positive 1. Because it was negative 1, we took it, we flipped it, and made it positive. And then for number 9, Aaron, can you say it again? Negative. So you would take it, flip it, it was positive, make it negative. Any others in this section? Or any questions we have in general on this? We're going to skip the next section and come back to it. Look at the other packet you have. Now we have to write the equation that is parallel to the one that's given. So of this section, which ones we want to see do go over review?
Yeah.
3.
8.
8. Any others in that section? 6. Let's start with 3. The equation we write has to be parallel, so the slope has to be the same. What would the slope be? 4/3. Then we're going to use that slope and a different y-intercept, it can't be the same, to write our equation in y equals mx plus b format. So y equals, our slope is 4/3 x. Take a y-intercept that's not 6. Sure. Good, that's it.
Why can't we use 6?
Because then there would be the exact same line and there wouldn't be two different parallel lines. Other questions on that? Alright, for 6, think back to your Hoybucks. What type of slope would this have? 0. If we're making something that's parallel, it has to look just like this, but can't be -6. So someone give me a number. Sure. That would work. You could have also made it the positive version, y equals 6, instead of positive 6, -6. That would work. Just can't be the exact same. Questions on that?
The sign doesn't have to stay the same.
Or this?
Yeah, right. I cut it so if the student was originally +6, I could just pick -6. It doesn't have to be a 1.
No. Okay. Right, and then 8, and then we'll pause for lunch. What would the slope be for this if it's parallel? -1/4. So when we write our equation, y equals -1/4 of x, give me a y-intercept.
-3.
-3 works. When we come back from lunch, we'll do the next section. Okay, in this next section, we are writing equations that are perpendicular to the one that's given. This goes on to the next page. Which of these do we want to see to go over review?
10. 12.
Any on the next page in that same section? Okay, so starting with 10, what would the slope be if it's perpendicular to this one? You have to think about your negative reciprocal. Take it, flip it. If it's negative, make it positive, and vice versa. So then when we write the equation, y equals 2 over 7x, this can be whatever y-intercept you want to include the one that was given. So it can be the same, it can be different, it doesn't matter. Someone tell me a y-intercept. Sure. I'm going to just leave it blank. That'll be 0. Questions on that? For 11, what would the slope be if it's perpendicular? Make it, flip it, it's negative, so make it positive.
So we see it as a whole number here, but if we were to flip it, what would the fraction itself look like?
It would be a half. You have to remember that all your whole numbers are really over 1. So when you flip it, it becomes 1/2. So when we write our equation, y equals 1/2 x, give me a y-intercept. What do you say?
He says 99,000.
Sure.
You see?
You can really pick whatever y-intercept you want, as long as it makes sense. Except infinity, because that's, like, it is a number, but it's not at the same time. Don't use infinity.
That makes no sense.
You can think of the highest number possible numerically to write, but not infinity.
What about the infinity times?
That's not a number. Right.
Oh, it is a number.
Someone just gave that answer. You can be whatever y-intercept you want. They just said that randomly. If you want to put 5, that would also work. For 12, what would the slope be if it's perpendicular? It's already negative, so it would have to become positive. So when we write our equation, y equals 1x or just x, give me a y-intercept. Yes, except infinity and negative infinity. But someone said 2. So I should say any number you want except for infinity, negative infinity. You can't put like plus apple, that wouldn't make sense. Alright, questions on this? On the next page, any other questions in this section, 13 through 16? Okay. So still perpendicular, what would the slope be if it's perpendicular to this? And then if we're writing our equation, y equals negative 2 over 3 x, give me a y-intercept. Alright, this isn't on yours, but this is. So the next section has graphs. Look at those, and there are 2 on the back. Find which ones you want to see, do, go over, review. $35. Okay, so we'll start with 34 and then do 35. If we need to do any others, we'll go back to those. So in this section, you have to write the equation that is both parallel and perpendicular, 2 separate equations. to the original. So let's figure out what the original is first. So look at the graph. Find your y-intercept where it crosses the y-axis. Look for another point on the line that crosses the background grid lines exactly. Any of these points would work. And then we can count our slope from any of those points. So it looks like we're going up 1 to the right 2. So that would make our equation y equals 1/2 x minus 4. But that's not the answer to our question. That's just us finding the original. Then we have to come up with an equation that would be parallel to the original and one that would be perpendicular to the original. So someone give me an equation that would be parallel to the original. The slope has to be the same, the y-intercept has to be different. So what would the slope be?
The original slope is 1/2. What's the parallel slope? 1/2.
Also 1/2. So the equation would start off y equals 1/2 x. Give me a y-intercept. Okay. So that one is parallel. Now we have to write an equation that's perpendicular. Someone give me an equation that would be perpendicular to the original. But it would be negative. So negative 2, and you would simplify, so just negative 2x. Give me a y-intercept. Three works. Do we have any questions on how we found the original, or the parallel, or the perpendicular? Okay, let's do 35. Same thing. Find the original first. Y-intercept I can see is at -5. Find another point on the grid lines that cross the grid lines exactly. What would that slope be? -1. Because we're going up and left or down and right. So y equals -1x minus 5, or just -x minus 5. What would be an equation that's parallel to that one? The slope would still be 1. Ari, what did you say? That would be for the perpendicular. I'm sorry. The positive would be for the perpendicular. -1 would be for the parallel. Plus what? 2. Plus 2. So then for the perpendicular, Ryan started to say y equals +x. Give me a y-intercept. Any others in this section we want to see, go over, do, or, yeah?
So, go over the parallel equation. You just put +2 as like current
You just pick a different y-intercept.
Okay.
The slope has to be exactly the same though. Okay. Go back to the first packet we were on. And find this section. Find which ones you want to see, go over, do review. Okay. And this goes on to the next page. $13. 16. So we'll start with 12. First, before anything, you need this formula. You may remember it. Our point slope formula, y minus y1 equals m times x minus x1. Where m is your slope, x1 and y1 are numbers from an ordered pair that you'll be given. X and y are just x and y. They're just variables. Okay, so for 12, if this is parallel, the slope is going to be the same. We're going to use this same slope, negative 3 over 5. The rest of that equation doesn't matter. So you can cross it out if you want, or just know that you're ignoring it. The ordered pair that you're given is your x1, y1. So now you have all the things you need to use this equation. So you're going to start off, y, this is always a variable, minus 0 equals negative 3 over 5, parentheses, x is always the variable, minus a negative 5. Once you get the hang of it, you can just put plus if you have two negatives, or minus a negative. Before we do anything with this, this has to combine and become a plus. But y minus 0 would just be y, so we can get rid of the 0. Then you would distribute the negative 3/5. This would just become negative 3/5 x. Multiply negative 3/5 and 5. How many did you get? So this is the equation that is parallel to the one that was given, and that goes through that point. Before we continue, what questions do we have on that process, or how we got that answer? Okay, going on to the next page. 13 is also parallel, so the slope is again the same. You're given your x1, y1. If you want to rewrite your formula up here so you don't have to flip back and forth, you could do that. And then we can start to put things in our formula. Y minus y1 is negative 2 equals 5 over 3 x minus a negative 3. Both of these have to become a plus before we can do anything else. And then we can distribute. So this becomes 5/3 x. What would this part be? 5/3 times 3. 5. Positive 5. If we have to get it back in slope-intercept form, what would be our last step? We have y equals 5/3x plus 3. This would be parallel to the one that was given, that goes through that point. Do you have any questions about that one? The last one is perpendicular. So that means we have to change the slope before we do anything else. What would our new slope, or the slope that's perpendicular to this, be? Positive 4. Flip it, make it positive. So then we don't need any of that. Then we could continue. We have our x1 and our y1. It's going to be minus no matter what. So y minus 2 equals 4 times x minus 1. Then you can distribute. And solve for y. So in this case, add 2 on both sides. So this line would be perpendicular to the original and go through that point. Do you have any questions on that one, or any others that we want to see do go over? If not, the remainder of class is yours to practice. You can go through the ones we did not do and practice those. Go back and do Khan Academy from Unit 8 or any of the ones on the board from the past, from today, last lesson, and the lesson before that. Find those names and dates. Go back and do those. Or if you haven't finished a test, or you said you wanted to work on retake, you could work on retake work today in class. To make sure you are using this time wisely, let us know